Alright, here we have lecture 3.3, Scatterplots and Correlation. Now, a scatterplot is a set of points plotted on a plane. All data is quantitative. So, naturally, if you're going to be plotting points, all the data has to be numerical. So, both the x-axis is based on quantitative data as well as the y-axis. And we have an example of a scatterplot tracking GPA and attendance rate. So basically, each one of these little x's represents a student, and we can see their GPA with respect and their attendance rate. So let's go ahead and see how a scatterplot is made in this first example here. We got height and weight. Height in inches, weight in pounds. And note that the lowest height is 58, and the highest or largest height value is 72. So we want to capture all those. So we'll start at 0 and introduce a break. So that little symbol just means there's a break in the graph showing we're skipping ahead from our standard interval structure. And let's just go ahead and start at 55 and go to 75 in increments of 5 will work. So 55 inches, 60, 65 inches, 70, 75 inches. And that will cover all the height values. Now our weight values, the lowest is 155 and the highest is 200. So we'll go ahead and go in increments again. We'll have another break. We'll go ahead and start at 150, 160, each tick mark representing 5 pounds, 170, 180, there we have 190, and then 200. And then every hash mark there represents 5 pounds. And let's go ahead and plot the points. So the first data point is at a height of 60 inches and a weight of 160. So you go to the x value 60, y value 160. Plot the dot there. Next one is at 63, 161. So it's halfway in between 60 and 65 roughly. And at 161, so slightly higher than the last dot. Then we got 58 and 155. So that'd be right around there. And then we got 65 at 180. Right there. And then 72 is at 200. There we go. So there's the scatter plot for our 5 data values. Now let's go ahead and talk about studying scatter plots. And when discussing scatter plots, we're often looking for a correlation. A correlation is a statistical measure that indicates the extent to which two variables fluctuate together. And we'll be looking at positive correlation and negative correlation. A positive correlation describes a pattern in which the variables increase or decrease together. So as one variable increases, so does the other. As one variable decreases, so does the other. So they kind of move together. A negative correlation means as one variable increases, the other is decreasing. So they're kind of doing the opposite directions. So let's go ahead and look at this example. And let's suppose I have a 3-day forecast, and it might look something like this. Some breaks here. 50, 60, 70, 80, 90, 50, 60, 70, 80, 90, and let's go ahead and look at it. So perhaps the forecasted temperature is 50 degrees and the actual temperature is slightly higher than that. And then on a different day, the forecasted temperature is 55, but it's actually 60, and so on. So if you were to graph these from a 3-day forecast, it might look something like this. Maybe one day they say the forecasted temperature is 90, but it's actually 80 degrees, so that dot would go there. And then let's look at the same thing, but for a same-day forecast. So let me just get my quantitative data set up. Suppose it looks more like this. So let's go ahead and look at these two scatter plots. So both of these demonstrate positive correlation. So let's look at the 3-day forecast. Note, as forecasted temperature gets higher, the actual temperature gets higher. As forecasted temperatures are lower, the actual temperature is lower. Same thing with the same day forecast. As forecasted temperatures increase, so do actual temperatures. As actual temperatures decrease, so do forecasted temperatures. That indicates a positive correlation. Now, which appears more accurate? That would be the same day forecast. So a correlation is stronger if the data values are clumped more closely together and they're less scattered. So we can see in the 3-day forecast the data points are a bit more scattered than they are for the same day forecast. Notice that they're packed much tighter together in the same day forecast. That indicates a stronger correlation. Whereas if they're more scattered apart, that will typically indicate a weaker correlation. Now we can actually measure the strength of a correlation numerically via something known as a correlation coefficient, but that's a little bit beyond the realms of this class. So let's go ahead and take a look at what positive correlation, negative correlation, and no correlation look like. Notice positive correlation looks like an upward trend in the data. As X values increase, so do Y values increase. As X values decrease, Y values decrease. And what that creates is what appears to be, reading from left to right, an upward moving trend line. Whereas with negative correlation, as X values increase, the Y values decrease. In other words, visually speaking, that appears to form a downward leading trend, reading from left to right. Now, of course, no correlation, just it looks like there's no apparent pattern whatsoever. So let's go ahead and look at this next example. So here we have ambient temperature versus hot coffee cells. Is it a positive, negative, or no correlation? Well, if we look at the data in the scatter plot, that definitely is a negative correlation. Note the kind of downward trend of the scatter plot. Now, correlation does not necessarily mean causation, right? There appears to be a pattern between these two variables, but is that pattern a coincidence? Is there some common underlying cause, or is it a direct cause? So look at the variables. One represents ambient temperature, so temperature outside, and the other represents hot coffee cells. Well, I would say there's a common underlying cause here. All right, the outdoor temperature does not directly affect hot coffee cells, but it does have a common underlying cause. They are related. Right? One does not directly cause the other, but they're definitely related. Right? As temperatures go up, hot coffee cells go down. Right? You're not going to sell as much hot coffee when it's 100 degrees outside, but when it's 30 degrees outside, you'll probably sell quite a bit. So there is a connection there. Now, that begs the question, well, what is a direct cause? So a direct cause means one directly causes the other. So that would be like a scientific law, like Boyle's law with pressure and volume. Right? If I have a container with the gas inside of it, the smaller that container is, the more I squeeze it, the higher the pressure will be. Decreasing that volume directly causes an increase in pressure. So that's an example of a direct cause. But let's go ahead and wrap up with a few more examples. Again, just another warning here. It's very important to note this. Correlation does not mean causation. Just because there's a pattern between variables does not necessarily mean that one causes the other or that there's anything meaningful there. It could just be a coincidence. So let's look at number one. Is it positive or negative correlation? Ice cream sales increase as temperature outside increases. So one is increasing as the other is increasing. They're moving together. That's a positive correlation. I would say that's a common underlying cause, right? Those are related. Pressure increases as volume decreases. So as one goes up, the other goes down. That's a negative correlation, and that's a direct cause. That's actually a law you'll learn in chemistry class called Boyle's law. Number three, GPA decreases as attendance decreases. So as GPA goes lower, we see attendance rates going lower. So we see that correlation. That is actually a positive correlation. Remember, a positive correlation means the variables move together kind of in the same direction. As one goes up, the other goes up. As one goes down, the other goes down. They're So this is a positive correlation. So don't let the word decreasing fool you there. So Game of Thrones ratings are increasing as violent crime rates are decreasing. This is a negative correlation. Variables tend to move in opposite directions. And this is what I would call a coincidence, right? Purely coincidence that there appears to be some correlation between Game of Thrones ratings and violent crime. Clearly those wouldn't have any real connection. Alright, well that's a wrap for this lecture. So kind of a short lecture just over scatterplots and correlation. So please make sure to watch this. You will have an assignment pertaining to these topics. So you want to make sure you review it, take good notes, and have a wonderful day.